So you might be thinking, is a significant effect good? As engineers, we often think that significance should either be a good or a bad thing. So think about normality testing, where significance is quote unquote bad because we fail to assume normality, which is required for capability analysis. ANOVA should not be approached with this good-bad attitude. It really depends on what we're testing. So remember, significance does not mean good or bad. Significance just means that we see a significant difference in one of our treatments. Okay, let's take a look at two examples where we can kind of, as engineers, not statisticians, as engineers, assign maybe a good or a bad, just to show you that truly it depends on the scenario. So in our first example, we're using a one-way ANOVA to test the effect that our manufacturing lines have on a dimension of our product. In this case, we don't want a significant effect. So in this particular example, this is showing an example where we're hoping that we don't find a significant effect of one of our treatments because we want each line to produce the parts the same way so that we can justify producing it on multiple lines. We want our product to come out the same whether it's on value stream 1, 2, 3, or infinity, because we want, as a manufacturer, to be flexible so that we can use the flexibility of our value streams to keep up with scheduling. So that's an example that shows you why ANOVA isn't good or bad. It depends on your scenario. Example number 2. We're using a one-way ANOVA to test the effect of processing temperatures on cycle times so that we can minimize our cycle time. So we already know that our temperature doesn't affect critical dimensions. We performed an ANOVA and we said, yep, everything is statistically all right. We are just fine. So what we want to know is we want the effect of our temperature to be significant on our cycle times so that we can pick the one that reduces our cycle times. Right? So again, this is an example that shows you not good or bad. It depends on your scenario and what you're looking for. In this case, we want to reduce cycle times. So we're hoping that one of the temperatures has a significantly lower cycle time than the others. Now, let's say you're testing at your process nominal and you want this to be wider. You want your validated temperatures to be wider than your non-validated temperatures. In this scenario, you might actually switch and say, well, no, we don't want there to be a significant effect because we found a temperature that works, has a minimum cycle time. We're going to focus in a little bit on a smaller temperature range right around, let's say it's at that T3 where, maybe there's like a dip in cycle times right at that T3. And so what we want to do is we want to take T2.1 to T3.9 and we want to see no significant difference in there. So again, this is just trying to drive home that don't think of significance as pass-fail, okay? Think of it as there's an effect going on here. Our independent variable is has a significant effect on our dependent variable, and now further testing is required to figure out what that significant effect is so that we can maximize whatever it is we're trying to maximize. Okay, so in conclusion, for engineers, ANOVAs are an incredibly useful tool, and they open up the world of process optimization. They allow us to evaluate the significance of independent variables or treatments on dependent variables in our products, enabling a better understanding of how our process parameters affect final products. Again, ANOVA is one of the foundational tools of an engineer. So get used to it, get familiar, understand the math behind it, and we can really do some amazing things. So, as always, thank you so much for watching. Have a great day, and please, with your new ANOVA skills, do something awesome.